Well, now we can do question 3. The question says, show that square root of x over x plus y over square root of x can be written as square root of x open bracket y plus 1 over x. Now, first, we can see the answer, the solution. Then first thing is that to rationalize this fraction, okay? So we can start by writing square root of x over x plus y over square root of x. So to rationalize our times by square root of x over square root of x, okay? Then this will be square root of x over x plus y root x over root x times root x makes x, okay? Now that the denominator are common, we can combine the numerator. This will be, excuse me, root x plus y root x all over x. Now note that here we have like root x, there also root x, so we can take root x as a common factor. So we can write root x as a common factor because it is a common factor of if I take root x out, note that root x can be written like 1 times root x, okay? If I take it out, so in the fact it's gonna be like 1 plus y here all over square all over x, okay? Which is basically this. If I rearrange, this can be written as root x y plus 1 over x. Proven. Well, we're now going to talk about rationalizing the denominator. And then, first of all, what is that? What is rationalizing? Rationalizing is simply means writing a fraction without the square roots at the denominator, like as we see here, there, and there in these questions. So we don't need to see a square root symbol or a surds at the denominator. But why is that? You know, it is because we can't really divide a number by something that never ends, okay? Because a square root here, let's take an example, square root of 2, for instance, will be like, if I press ST there, you notice that the decimal parts, actually the decimal never ends. It continues endlessly and there's no pattern here. There's no pattern to write in the fraction form. So, or if I take a larger screen, I say like a square root of 2, you see the decimal parts it's even the decimal parts, the digit of the decimal parts continues endlessly and with no pattern. Now, it's meaningless to divide something, a number or a fraction or root by something that never ends. That's why we rationalize. And another thing is like, you know, multiplication by 1 is just that number. It's called, multiplication by 1 is neutral. It's a neutral, 1 is a neutral element of multiplication because a times 1 is just equal to a. And there are many ways of writing 1. You know, I can even say infinite way of writing 1. 1 is the same thing as 2 over 2. It can be -3 over -3. It can be 5 over 2 over 5 over 2. All this makes 1. It can be pi over pi. All this is 1. Okay, it can be square root of 2 over square root of 2. So all this is just equal to 1. Okay. Now, to rationalize now these questions, let's start with A. That is 3 over root 6. If I need to rationalize it, I'll say I'll multiply this by root 6 over root 6, knowing that root 6 over root 6 just makes 1. Okay, so if I multiply this, I didn't really change the value of this, but it will just look different. It will be rationalized because this will make 3 times root 6 over root 6 times root 6. And then this product here will cancel the roots, and then that makes 3 root 6 divided by 6. now this expression is rationalized. Okay, same way we can do b, that is root 8 over root 3. Here we will times by root 3 over root 3, which is just 1, and then doesn't really change the value. It doesn't affect the value of the given expression. And this will be root 8 times root 3 makes root 24 over 3. Okay. Or before even I do that, let's first simplify. Root 8 is like let me simplify this. Root 8 is like 2 squared times 2, okay, over root 3. And then this is like root 2 squared times root 2 over root 3. And then this makes 2 root 2 over root 3. Now, to rationalize this, I'll times here by root 3 over root 3, which is just 1. And then it doesn't change the value of the given expression. And then this will be like 2 root 6, okay, because here we'll times the radicand, okay, with the same roots, and then the denominator will be just 3. Now we can also do c. C is 2 over 5 root 2. I will times here by root 2 over root 2. And then this will be 2 root 2 over 5 times 2. Okay, and then that makes, we can simplify now this 2 with this 2, and then the answer will be root 2 over 5. Okay. D was 3 root 2 over root 8. On this, let's first simplify. That makes 3 root 2. Root 8, we did prove it there by question B. It was 2 root 2. Okay. Now, over here, we don't need to multiply by root 2 over root 2 because we have root 2 there. We can just simplify this and that. And the answer is just 3 over 2. Okay. And then we can also do E, which is 3. And then there we have the cube root of 9. Now, over there, we multiply that by the cube root of 9. And then this will cancel the cube root at the denominator, and then that makes like 3 cube root of 9 over 9. Then we can simplify. Note that cube root of 9 is not, we cannot simplify this because this is 3 squared. It has to be 3 to the power 3 to cancel the roots, okay? And then we can simplify 3 with 9 here, 3 left there, 1 there. And then the answer is just cube root of 9 over 3. Thank you. Well, we have another question here that says rationalize the denominator of the following expression. Okay. Contrary to question 1, here we have like terms at the denominator. So in cases like this, we cannot really multiply by 1 minus root 3. See what will happen. If it was, for instance, let's say here I did like 2 over 1 minus root 3, and I multiply this place by 1 minus root 3 over 1 over 1 minus root 3, like that. This will be at the denominator is gonna be like 1 minus root 3 to the power of 2 under 2 open brackets 1 minus root 3 and then this will be like 2 minus 2 root 3, and then the denominator will be 1 minus 2 root 3 plus 3. And then notice we still have a root here. It said there is not really simplified. Even if I continue, I get like 2 root 3 there, and then over it's gonna be 1 plus 3 makes 4, 4 plus 2 root 3. So we still have this. It says there. Even if I simplify again, I take 2 as a common factor, there it's gonna be like 1 minus root 3 over 2 plus root 3. We simplify this and that. In this case, it's 1 minus root 3 over 2 plus root 3. You see? And then if I multiply again by 2 plus root 3 to cancel the denominator, I'm going to have another root at the denominator over and over and over and over. So it's not really the way of solving this problem. In this case, rather, when we have like terms at the denominator, we can multiply by the reciprocal. Why? What do I mean by reciprocal? I'm saying reciprocal is like if I have A minus B, the reciprocal of A minus B is A plus B. This is the it's not the reciprocal, I call it like that, but it's, I guess, not the reciprocal. The reciprocal is like the inverse, but it's the composite or whatever it is. All you may know is like if it's A minus B multiplied by A plus B, or and vice versa, okay? And vice versa. So, if for instance, 2 over 1 minus root 3, okay, in this case, we're going to multiply this by 1 plus root 3 over 1 plus root 3. Why? Why is that? See what it's going to be. It's going to be like 2 open bracket 1 plus root 3. And there at the denominator, this product here, okay, it's going to be like 1 minus root 3 multiplied by 1 plus root 3. This makes a product that leads to the difference of 2 squares, okay? So it's going to be, the numerator is going to be, if I times, so it'll be 2 times that, 2 times that, that makes 2 plus 2 root 3. That's going to be like 1 minus root 3 to the power of 2. Root 3 to the power of 2, okay? Root 3 to the power of 2. This and this cancels out. This will be equal to numerator there. Let's keep it as it was before. 1 plus root 3. Okay, over 1 minus 3, right? And that makes 2 open bracket 1 plus root 3 over negative 2. And then this will be equal to negative 1 plus root 3. Okay, that's the answer. Or negative 1 minus root 3. That was question A. And then, excuse me, we can do question B this the same way. That makes root 7 minus 2 under 4. In this case, we're going to multiply root 7 plus 2, okay, and then root 7 plus 2 there. Now this will be equal to what? That makes like root 7 plus 2. Root 7 plus 2. Okay, excuse me, minus 2 here. And then plus 2 there. Under 4 open bracket root 7 plus 2. Now this will be what? At the denominator it will be difference of 2 squares. So that makes 7 plus, not plus but minus 4 under 4 open bracket root 7 plus 2. Okay, and then that makes 4 root 7 plus 2 over 3. We can also do question C the same way. Question C, which was root 2. Root 2 under 4 plus root 2. So we're going to multiply this by 4 minus then root 2, and 4 minus root 2. We know this is just 1. Okay, so it doesn't really change the value of the given expression. And then this would be like root 2, open bracket 4 minus root 2, over the difference of two squares here. 4 squared is 16, and then negative root 2 to the power of 2 is 2. And then this will be this times 4, and this times there, and then this is going to be like 4 root 2 minus 2 all over 14. Okay, and then we can even simplify this, because we can take 2 for common factor, and then this will be 2 roots 2 minus 2, no, minus 1 over 14. Then we can simplify this and that, left with 7, and then that will be 2 roots 2 minus 1 over 7. Okay. Now